Hello, welcome. This is my second video on the Incan Abacus. Got my coca here because it's legal where I live. There's some leaves right there. So let's get started. Okay, so I want to do just a couple simple math problems. I'll do some multiplication. Probably in some future videos, I'll do some addition and subtraction with using it in a base 10, using it as a base 10. And I also want to show in some future videos how, because we're using it as a base 40, right? 1, 40, 1600, and so on. If you take this out and you're just to have that part right there, you can see with the three line, the 12 squares, you can use it in a in a base 15, where this is 1, this is 15, this is 225, and so on. For me, it's actually easier kind of to do it that way. Numbers tend to divide and multiply very easily, but you can't do as big a numbers. This, if you just had these, you can use it in what apparently is a base 5. From what I can tell, I'm not sure if it would be called a base 5 or a base 6. But again, I believe I might be wrong about this, I believe this dot here winds up being a 100. And so again, it's extremely easy to do it that way, but obviously you can't go very high. So this, the more I study it, the more amazed I am at it, and it seems like an extremely natural way to deal with numbers. And I found out about this probably a little over a year ago, and for some reason it just caused me to obsess over trying to figure out how it worked. And still to this day, I'm not really sure I understand it that well. It's complete genius. I mean, just the fact that the numbers, the amounts of dots in these squares are basically, well, you know how if you use a decimal system's okay for adding and subtracting, and I suppose multiplication, even if you're in division, if you're going to do math the way that we're taught to do it nowadays. But if you're going to do fractions, decimal system is not good at all. You want to use a 12-base system, right? Because how many ways can you divide by counting to 10? In the decimal system, only 2 ways, right? It only divides it by 2 or by 5. You do fractions with it, it's pretty crummy, right? With 12 is awesome because you use a 12 base system. You have 12 digits to play around with. You can divide by 2, 3, 4, and 6. You can't divide by 5, but dividing by 6 does the same thing. It gives you half, right? And so there's no 4 in here, as you can see. It follows the Fibonacci sequence, but these two together stand in for 4. Or having 2 rocks here stands in for 4. So there's actually, even though there's no box with 4 dots in it, there's actually more ways to represent 4. Crazy. Okay. Well, let's get started. Let's do a couple problems just to show you the basic outline of it and how it works. Let me show you how a few numbers would look, right? This is 1, this is 2, this is 4, okay? This is also 4. So the pattern is, and this is how the Fibonacci sequence works, right? 1, 2, 3, 5. Whereas binary is 1, 2, 4, 8. Binary multiplies a lot faster. But the Fibonacci sequence has its pros, right? It doesn't you can't go quite as high, quite as fast, and the reason why again is because with the Fibonacci sequence, every number, every step in the Fibonacci sequence only equals the two numbers that are behind it. So you add up the last two numbers and you get the next number. Where with binary, each number represents all of the numbers, all of the steps behind it, right? Plus one more. Whereas this is that each step is equal to both of the two numbers behind it, but none behind that, right? So you can see that the 3 is obviously equal to the 2, 1 and the 2 that are behind it. The 5 is equal to the 2 and the 3 that are behind it. And it's also true that we have 4, we have 2 here. But if we take these two and we move them sideways, one this way and one this way, we get the same number. And that's another fascinating thing about this Fibonacci sequence. So let's do a simple problem. 8 times 2. 3 and 5, right? Each dot here equals 5, and the whole square equals 25. Each dot here equals 3, and the whole square equals 9. So one rock here is 5, the other rock here is 8. So we want to multiply that by 2. What do? We just throw another rock in there and another rock in there. And you get 10, 5 plus 5, and 3 plus 3. So we get 16. So what if we wanted to do 8 times 3? Now what we're going to do is throw 3 rocks in here and 3 rocks in there. We have 25, right? Or 24, excuse me. So if you want to represent the number 25, you have to have 5 rocks in here, right? 5 times 5, it's all full. What if you want to represent one digit less? You want to represent the number 24. You have 3 rocks in here and 3 rocks in there. That's going to give you 24. So the more you play with it, the more you see patterns, right? Oh, excuse me. No. Let's see what I have written down. 6 times 5. So take the number 6. That's 5 and that's a 6. So first I need to do this 5 6 times, but I already know that this whole square is 25. So I have to have 5 in there. And I have to have 5 more. Oh, how am I going to represent another 5, right? I need to represent the number 30, right? 6 times 5. Well, first, I could do the 5 times 5, and we have that right here. But we have one more. Obviously, I just put a 2 and then a 3. Take that away. Now I have my answer, 30, 25, 3, and then 2. Okay. I want to do a bigger number. Let's do 15 times 8. Now, I talked about how it's easier to use the number 8. The number 8 on here just kind of flows well. It's easy to use. Simply, in the same way that if you're using a decimal system, you're going to use 10 is going to be an easy number to multiply and divide by. Anything times 10 is going to be easy. Anything times 5 is going to be easy. On here, anything times 5 is fairly easy as well. Anything times 8 is easy, and the reason simply is that 5 times 8 is 40, and this is 40 base. So any rock that I have here, If I multiply it by 8, because it's 5, I just know that I'm going to move it there, and that's 40. If I have 2 rocks here, I move to the square. Instead of 40, it's going to be more than 40, right? Because now it's 10 times 8. What's 10 times 8? 80. So I just move the rock there. What if I have 3 rocks here? 15. It's 15 times 8. Do I take all 3 of these rocks and put them here? Basically, the rules state that you're not supposed to have multiple rocks in one square. I mean, you can really do it without ever having more than one rock in each square, which I'm going to show you in this video. You don't need to have all these piles of rocks. Well, you don't need to do that because if you have 3 here, you just take 1 and put it in a square with 3 points, right? So pretty simple. If I have 1 rock, I multiply by 8, I go to the square with 1 hole. I have 2 rocks, multiply by 8, I take a rock and put it in the square with 2 holes. I have 3 rocks, I want to multiply it by 8, I go ahead and put 1 rock in the square with 3 holes, right? Because this point equals 20. Each of these equals 80, and the entire square equals 160.